Hello, Assalamu alaikum. In previous class of A levels, we did number systems, conversions, and two's complement and BCD. Today we will continue with the data representation, same chapter from the booklet 1.1, and we will going to do images, and we'll also try to cover up the topic sounds as well. Okay, so let's get back to the business. All right. So you already know that the resources that you can use the website, you can go to AS levels, and the topic which I'm just talking about right now, that is data representation. This one, 1.1, information representation, right? So I have the copy of this already downloaded with me. And after downloading it, if you go to page number 17, you will get this images. Okay, because it's about the information representation or data representation, how it can be done in a digital form in computers. We just not only going to talk about the numbers only, the written data, the ASCII charts or the Unicodes. We also need to represent data in a form of images, videos, in a form of sound. So we will going to discuss everything regarding that. Images. Let's start with two types of images: the bitmap and the vector images. So the bitmap image is often what you take a picture from your camera, your smartphone camera or your digital camera, and it try to record the image of the real world. All right, and it store it digitally. But when you take a picture from the real world and when you just try to store it digitally inside a computer, it stores pixel by pixel. Okay, and it doesn't matter how better the quality camera have, how the number of pixels does it have. Okay, these days we are witnessing 1.8 megapixel cameras in the smartphones, but yet it doesn't matter how much details they have. If you will start zooming a bitmap image, at some level it will start pixelating. Okay, but when we talk about the vector images, the other type of the image that is completely designed in a computer using some software, maybe Adobe Illustrator or the Microsoft Publisher, anything. If you zoom that image, it starts realigning itself because it's designed in a computer, and every image that either it's like in a form of circles, lines, or triangles, they are created that way. The values of those images recalibrate according to the zoom that you do. So that's why vector images, they do not pixelate. You just keep zooming them, they just keep realigning themselves, and they still look as sharp as they are. So these are the two types of the images. Then we have some examples here which you can definitely study, and some references which you see on a daily basis. What is 720, what is full HD 1080 or 1920, what is 2K, what is 4K, and VGA and other references as well. Then this calculating screen resolution, it's like a piece of cake. It's just multiplying the number of pixels in width and number of pixels in height. You just multiply them, you're going to get the total number of pixels in a screen, an LCD or any screen. So and then there are some really good questions for your practice, for a quick revision. So these all things are easy. The thing which is required to be done is this one. It's the color depth. In color depth, let's talk about here on the whiteboard. We know that when we talk about the color depth, it means that if there are number of pixels in a screen, we know that an image on a screen is made up of dots, and we call those dots pixels. and each single pixel can be of different colors, and the ability of each single pixels having different colors means that that screen can represent this much colors in any particular image. So more the number of colors can be represented by each pixels means that that screen can shows more colors, more vibrant colors in an image. So it's mean that if let's suppose if we assign only 2 bits to each pixel of that screen, every single pixel, every single dot will going to acquire 2 pixels, then it's mean that that screen can have 4 colors. All right, how's that? For example, either 0 0, it will going to, let's suppose, have a color white. All right, 0 1, this combination, if that combination will be placed in that pixel's memory, 2-bit memory, that can make light gray. If it's 1 0, that's dark gray, and if it's 1 1, it's mean it's black. I'm just giving you an example. Okay, so if 2 bits, it's mean 4 colors. 2 bits per pixel, 4 colors. Or you can have a formula, 2 raised to power n, where n is number of bits is equal to, and you have number of colors. So for example, if you've been told that it's a 256 color screen, how many number of bits are required per pixel? You just try to find the value of n. You know that if you put 8, it will going to make 256. So 8 number of pixels per 8 number of bits per pixel. So this is how you calculate the color depth. The last thing that we must know is this. For example, they talk about red, green and blue RGB colors in screens. When we talk about the printers, they talk about cyan, magenta, yellow and a black color. If you just want to have a hard copy output through the printer, you have to have 4 cartridges, 4 different colors. And if you just want to show colors on a screen, the soft copy which you just want to see, that must have red, different combinations of red, different combinations of green, different combinations of blue, and by mixing a pinch of red, an amount of green and some portions of blue, they will start making different colors. And if you assign 8 bits, you already know that 8 bits make 256 combinations, 256 colors. Let's suppose if you, sorry for my bad drawing, let's do it this way. All right, 32, 64, I'm still missing it out. Just let's design it like this: red, green and blue. And this red will going to have 1 2 3 4 5 6 7. It's mean 1 2 64 and 128. So these are 8 bits. So if you assign 8 bits to red, 8 bits to green and 8 bits to blue. Now you know that if all the bits are 1, it will going to produce 256. So you start from 0 0 0 0 0 0 0 0 and then 1 2 3 4 5 6 7 up to 255. So this will going to produce 256 combinations. So you can have 256 different shades of red, same with the green and same with the blue. So if you multiply by 256, 256 for green in a similar fashion, and 256 for blue in a similar fashion. 256 multiplied by 256 multiplied by 256, it will going to make 16 M color. So this is how we can represent number of colors on a screen. So we were talking about color depth. After discussing all this, you can solve these questions which are given below to calculate different number of bits, different number of color depth required for a screen. You can definitely solve these questions on your own. Let's suppose if they ask you that this screen has a 256 colors, it's mean that you can immediately tell 256 color screens mean each pixel will going to take 8 bits. So 8 bits required per pixel. And if the resolution of the screen is also given, the width, number of pixels in width and number of pixels in height, you just multiply them, you get total number of pixels. You know 8 bits per pixel, you multiply it with that, and you're going to get your answer in bits, which you can later convert into kilobits, kilobytes, megabytes, and you can tell the answer. Each picture requires this much space to be represented on this particular screen. Okay, so such questions or the different variants of them are asked here for your practice. Yeah, vector graphics, the images, the graphics which does not pixelate. It doesn't matter how much you zoom it, they just keep realigning themselves mathematically. So how it's been done, an example is given here. Okay, so if you just look into this example, a rectangle is given, a circle is given, and a line is given. In a line example, you can also find the combinations of circle and triangle. So how to do this question? You can even do this on some online tutorials are easily available. We call them SVG, simple vector graphics, and you can just run the same code that is given here or over the web, and you can actually see the results. Okay, so just have a look what does they mean. Just take a snap of it. Okay, there we go. Yeah, that will work fine. Okay, if you look in a rectangular image, because if you need to draw something, you just need to draw it on a canvas or on a screen, so it must have some dimensions. So let's take an example that if these are the dimensions in x and y coordinates, and if you need to tell the position from where you need to start to draw your rectangle, so it's been mentioned like here, rectangle x 14 y 23. It's mean it's this is the coordinate for x. It could be like 14 from 1 2 3 4 5 14. We're just assuming, and this could be the 23. So this is the point. You need to tell this point of rectangle. This is important. Okay, and after that you just tell the width and height. Probably this is in a form of pixels, so it's telling us that you need to draw 250 pixels in this direction and 50 pixels in this direction. And after you have done this, it's mean your rectangle is being made. Now there are some further things which you can mention. You can fill the color green, or you can also give a color code hash FF0 F123, something like that, or you can also write it down like this. So if you have done some sort of HTML, you could have an idea about it. Any case, that is not required. Stroke black, this means the outer line that you can see, it must have a black color, and its width is 1, so it's a thin stroke. So these are the informations that you can put. Now let's talk about the circle. Same, the canvas x or y dimension must go there. Now the center point of circles start from here, the center point. So you have to give the coordinates of a circle by keeping that thing in mind, that it will start from the center. So x 100, y 100, like if this could be 100 and this could be 100, and then the radius, you just tell the radius then. And after doing this, the circle is made. It's 50, fill it with red color, stroke is black, you can see that, and width is 5, you can see that the stroke is thicker here. That's the reason. Okay, for a line, now because rectangle is also made here, the code is there, the circle is also made here, the code is here, and for the line, you have to provide the x1, y1, x2 and y2 because it's a line. So you have to provide the starting position, all right, and the ending position, both in x-axis and y-axis. So once you have done with this, the line will be drawn, then you can tell the stroke, you can also tell the color of the stroke, and how thicker the line will be, and what will be the color of the line. So now, by just drawing rectangles and circles and lines and cones and triangles, you can create any image. Now how it can be done, that's not the part of our syllabus right now, but I'm just letting you know that this is how the vector graphics are created. These are the base of vector graphics, and this is what we need to learn right now. All right, so vector graphics. After then, you have some questions regarding vector graphics versus raster graphics. Raster graphics mean the bitmap graphics, which is saved in the form of JPEG, PNG, GIF, etc. There are pros and cons, some questions regarding that. So there go our images. If you go down and look into the past paper questions, starting from page number 38, I'm pretty hopeful that you have solved the questions regarding number systems, 2's complement, BCD, etc. And then we have questions regarding this is regarding sound. Give one benefit and one drawback of using a higher sampling resolution. This is regarding sound. Run length encoding, that's in lossy and lossless compression. Yeah, you can find this question here on page number 54. The computer also have bitmap software. Define the term image resolution. The more the number of pixels or dots are there in a picture, it's mean the greater the number of resolution is. A picture is drawn and is saved as a 16 color bitmap image. That was the reason that I was explaining that topic with great efforts, because it's really important. You can see the question there. State how many bits are used to encode the data for one pixel. 16 colors, guess what? 16 colors, 2 power n to power 4. It's mean 2 power 4 means 16. So 4 bits per pixel, okay? And a second picture has width 8192 pixels multiplied by 256. It is saved as a 256 color. It means 8 bits are required per pixel. Then you have to calculate the data by multiplying 8192 with 256 multiplied by 8. The answer will be in bits. You have to convert it into kilobits and then kilobytes, and then your answer will be complete. So there will be more questions regarding that in same booklet. Please solve them. Our topic images is complete. I'll come up with the next class with the sounds, inshallah tomorrow or day after tomorrow. And please give me your feedback, stay connected, solve the questions, and see you guys soon. Allah Hafiz. There we go. Pretty hopeful that lights are okay. We also have to have a prayer break. Everything should be good.